We continue with the chapter direct and inverse variation. In the last two videos, we had done the exercise 9.1, which was based on direct variation. Now we are going to see the exercise 9.2, which is based on inverse variation. Now if you see in case of inverse variation, as I told you, the main thing what happens is that if one particular quantity increases, the other related quantity will decrease. If one quantity decreases, other increases. So it will be going like this. It will be going up and down. If one goes up, other goes down. If other goes down, other goes up. So in this way, it is going to be matching that way. So let's see. So of course, in this particular exercise, you will not only be having the direct variation but inverse variation, but maybe I think there should be some sums of direct variation also. So each and every time we will again check whether the question is based on direct variation or inverse variation and accordingly answer the thing. Okay, so as I told you, in case of inverse variation, what you are going to have is straight multiplication. That means that, see, in case of direct variation, what was happening in case of direct, we had that x upon y was constant. Okay, this was constant. Here in case of inverse, it will be saying x into y will be constant. Okay, so for different values of x and y, the product of x and y is going to remain the same. If the product of x and y is the same, then they are in inverse ratio. Okay, inverse proportion, inverse variation. If the product of the two variables is the same, then they are in inverse variation. If the product is the ratio is the same, then it is a direct variation. So this is the identification of whether the given terms are in direct variation or inverse variation. So let's see, now we go to exercise 9.2, and as I told you again, in inverse variation we are going to do straight multiplication. Okay, so when we do the sums, I'll tell you exactly what is straight multiplication. Question number 1, which of the following are in inverse variation? Number of students in the hostel and consumption of food. So we know that more the students, more the consumption of food, lesser the students, lesser the consumption of food. Okay, आज 5 जन अगर कुछ खाएंगे तो 10 जन उससे ज़्यादा ही खाएंगे, कम नहीं खा सकते हैं. So definitely the first one, so we can see in the first one, first is direct. Second one, time taken by a train to cover a fixed distance and the speed of the train. So yes, time taken and speed. If the speed is more, time taken will be less. If the speed is less, the time taken will be more. So yes, they are inverse ratio. So yes, the second one is inverse. We move on to the third one. Area of land and cost. We know very well, जितना ज़्यादा एरिया हम लोग खरीदेंगे उतना कॉस्ट उसका बढ़ेगा. So more the area, more the cost, right? So both the area and cost are going simultaneously upwards. Therefore, it is direct variation. See the fourth one. The number of people working in the time to complete the work. Okay, we know very well, more the people working, lesser the time it takes to complete the work. If one man can do the work in 10 days, automatically two men can do it in 5 days. Right? So more the people, lesser the time. So again it is inverse variation. So fourth is inverse. We see the fifth one. The quantity of rice and its cost. Direct variation, more the quantity, more the cost. So direct variation. So this is direct. So you can see over here that the answer for our question will be that second and fourth are inverse. Okay, second and fourth are inverse variation. That is what is there for question number 1. The number of students in the hostel. One second. They are given that first is also inverse. I'll just cross check that thing. The number of students in a hostel and the consumption of food. Number of students in a hostel and consumption of food. Okay, sorry. Consumption of food ka meaning is slightly confusing. Consumption is not the quantity of food but the number of days the food will survive, or we can say the number of days the food is going to be available. So you can see that if more the number of students will be there, the lesser the number of days it is going to run. Or so the consumption will be accordingly this way, it will be inverse. So that's why it is inverse. So by the term consumption of food, it means that for how many days the food is going to last. Okay, when by meaning the consumption of food means how many days the food is going to last. If I am talking of the quantity of food, yes, it is direct. More the number of students, more the quantity required. But if I say that how many days will a particular amount of food last if the number of students increase? If the number of students increase, the quantity of days will be decreasing. If the number of students decrease, the quantity for which the food is going to remain will be increasing. That's why it is inverse ratio. So 1, so that's why the answer is 1, 2 and 4 are inverse ratios. Okay, that is question number 1. We now move on to question number 2. In question number 2, you have got the same way the table, and you need to find out whether the given is indirect variation or inverse variation or not. So we need to find that which of the pair of x and y are in inverse variation. So that is second ka first, you have got over here x and y. This is 90, this is 10, this is 60 and 15, this is 45 and 20, 30, 30 and 20, 45. So here we know that for inverse variation, x into y is equals to constant. Okay, so we have got first one, 90 into 10 is equals to 900, 60 into 15 is equals to 900, 45 into 20 is equals to 900, 30 into 30 is equals to 900 and 20 into 45 is equals to 900. So since x into y is constant, therefore it is inverse variation. Okay, the given data is in inverse variation because x into y is constant. We see the next thing, that is second. You got here x, y, 75, 10, 45, 30, 30, 25, 20, 35, 10 and 65. So we know that for inverse variation, x into y is equals to constant. So 75 into 10 is equals to 750, 45 into 30 is equals to 15, 1350. So it's not. 30 into 25 is equals to 750, 20 into 35 is equals to 700, 10 into 65 is equals to 650. So since x into y is not constant, therefore it is not inverse proportion. Okay, so it is not inverse proportion because x into y is not constant. So that was sum number 2. We now move on to sum number 3. Okay, sum number 3. Under the condition that the temperature remains constant, the volume of a gas is inversely proportional to its pressure. If the volume of the gas is 630 cubic centimeter at a pressure of 360 mm of mercury, then what will be the pressure of the gas if its volume is 720 cubic centimeter at the same temperature? So you got over here that at 360 mm pressure, volume is equals to 630 cubic centimeter cc. Therefore, at the question 720 cubic, so x mm pressure, volume is equals to 720 cc. So we know over here pressure and volume. Pressure is 360, volume is 630, pressure is x, this is 720. Now you can see that it is given that is inverse variation, so you are going to straight multiply. Okay, so it is inverse variation. Therefore 360 into 630 is equals to x into 720. So x is equals to 360 into 630 upon 720. This is 2 and this will be 315 is equals to 315 mm of mercury. So you can see that the pressure, so pressure of gas is equals to 315 mm of mercury. Okay, that was sum number 3, 315 mm of mercury. We now move on to sum number 4. A packet of sweets was distributed among 20 children and each of them received 4 sweets. Okay, so we have over here 20 children received 4 sweets. How many sweets each will get if the number of children reduced by 4? Reduced by 4. Now it's very important to understand over here. Reduced by 4 means not, you don't take 4 over here. You take over here 20 minus 4 is 16. Okay. So you can say children reduced by 4. Therefore number of children is equal to 16. Therefore 16 children receive X sweets. So you get children and sweets. Children are 20, sweets are 4, 16 will be X. Direct variation, inverse variation. So it is inverse variation. Now it is, why it is inverse variation? You know very well that if then between 20 students, if you are going to get 4 each, the number of students increase, तो automatically क्या हो गया? और ज़्यादा distribute होगा सब लोग को, तो ज़्यादा मिलेगा, right? So accordingly, if the number of students decrease, this will increase, right? You can also keep an eye on that. If your answer is less than 4, that means you have gone wrong somewhere. So it is 20 into x is equals to 16 into 4. So x is equals to 16 into 4 upon 20. So that will be 5. How can it be? Oh, sorry. I said direct multiplication, but I did inverse relation, but I did cross multiply. So it is 20 into 4 is equals to 16 into x. So x is equals to 20 into 4 upon 16. So that will be as 5 sweets each. So therefore 16 children get 5 sweets each. So that's the answer for sum number 4, that the students will get 5 sweets each. We now move on to sum number 5. Pooja had enough money to buy 36 oranges at the rate of 4 rupee 50 paisa per orange. How many oranges she can buy if the price of each orange is increased by 90 paisa? Okay, so we know very well that if she has got enough money to buy 36 oranges, the cost of the oranges is going to increase, the number of oranges what she is going to get will be decreasing. So accordingly it's a inverse ratio. So we get over here 36 oranges if cost equal to rupees 4.50. X oranges if cost is equals to 4.50 plus 0.9 is equals to rupees 5.40. Because 90 paisa is being increased, there is an increase of the price of the orange by 90 paisa, so it will cost 5 rupee 40 paisa. So we know we have over here oranges and cost. 36 4.50 x, it is 5.40. That will be, it is inverse proportion. Therefore 36 into 4.50 is equals to x into 5.40. So x is equals to 36 into 450 upon 100 into 100 upon 540. 9 5s are 9 6s are 6 6s are is equals to 30 oranges. So we can say that Pooja can buy 30 oranges. Okay, the number of oranges what she can buy with the increase of the cost by 90 paisa will be 30 oranges. Easy, right? So you can see it was sum number 5. We now move on to sum number 6. Okay, sum number 6. It takes 8 days or for 12 men to construct a wall. How many men should be put on the job if it required to be constructed in 6 days? Okay, so we have got that if 12 men are working, the time taken to build a wall was 8 days. So how many men will complete it in 6 days? So you can say 12 men can build in 8 days. Therefore, X men can build in 6 days. So you can know that more the men, lesser the time taken. Inverse variation. So we have over here men and days. Men 12, days 8, men X, days 6. It is inverse proportion. Therefore, 12 into 8 is equal to 6 into x. So x is equal to 12 into 8 upon 6. That's going to be 16 men. So therefore, 16 men can build the wall in 6 days. Okay. So the answer to sum number 6 is 16. So 16 men will be required to build this particular wall in 6 days instead of 8 days. Are we clear with this? We now move on to sum number 7. Sum number 7. 8 taps through which water flows at the same rate can fill a tank in 27 minutes. If 2 taps go out of order, how long will the remaining taps take to fill the tank? So what we are given is that in 27 minutes, 8 taps can fill a particular tank. So if 2 taps are not working, so how many taps are going to work on it? 6 taps. So 6 taps will take how much time? Of course, more than 27, right? So that will be inverse variation. So we'll write the same thing again. We have over here 8 taps fill tank in 27 minutes. Therefore, 8 minus 2 is equal to 6 taps fill tank in X minutes. So you get taps and minutes. Taps 8, minute 27. Tap 6, and X. It is inverse proportion. Therefore, 8 into 27 is 6 into X. X is equal to 8 into 27 upon 6. So 3 2s are, 3 9s are, 1 4s are is equal to 36 minutes. Therefore, 6 taps will fill tank in 36 minutes. Is it clear? So this is how we are going to do the sums based on these sums, okay, though quite an easy one. The remaining 5 I'll do it in the next video.